start by recording this and shrinking it, and then bringing up my email. Snap left on that, bring that up, and no, I didn't get yours yet, but okay. There it is. Which one do you want to start on, the left or the right?
The right.
Wow. Again, interesting how each of these oh, there it is. I just hadn't expanded it enough. I'm going to start on 1.
Yeah.
Okay. If Harry is 20% faster than Pete, then what percent slower is Pete than Harry?
Isn't it just 20?
No, let's make up some numbers. Let's say Pete is 100.
Okay.
Well, what's Harry? If Pete can run 100 miles an hour, what can Harry run?
120.
Okay. Now, if I want to know how much slower Pete is than Harry, I have to take, what is this fraction? You have your calculator?
I'll get it right now. It's 5/6.
Okay. What decimal is that?
0.83.
So how much slower is Peter than Harry? Not 20%. What is it?
17.
Yeah. And that's always the case. The answer to these questions is always going to be different. Because in one case, you're using this as a base to calculate 20% faster. But in the second situation, you're using this as a base, 120. So that 20, you could also take the difference, 120 minus 100, and put it over 120. In fact, that actually makes a little more sense as to how we should do the problem. The difference is 20. He's 20 miles per hour slower. So we take 20, but we divide by 120 because we're comparing him to Harry, and this is Harry down here. And if you do 20 over 120, you get the 17%, or you get like 16.3%. How much do they want you to round these off to? The nearest decimal, the nearest hundredths?
It doesn't say.
No, I noticed that. And yet, right off the get-go, they give us a problem that leaves us with a fraction. Because 1/6 is actually 0.8333. So it's really going to be 16.66%. That's how much slower he is. Look at number 2. Victor has to practice for T minutes. After Victor practiced for D minutes, he stopped. What percent of his practice did he not finish? Well, the percentage of his practice that he did not finish would be how many minutes did he stop short, and divide by how many he was supposed to do it. So what would the fraction be? How many minutes did he actually practice?
You don't know.
Well,
2
no, he
minutes.
practiced D minutes. So how many did he skip? What's the numerator got to be? Forget looking at the answers for the moment. We're looking at C minus D is what he didn't do.
Yeah.
Okay. And what percentage did he not finish? Well, he was supposed to do T, right?
Yes.
Well, that gives you a decimal answer, which we have to multiply by 100 to turn it into a percentage. So if I multiply that whole thing by 100, I'll have the percentage. And that matches answer A. And I would do all of these percent problems like that. In other words, figure out the decimal first. This is the decimal. That's the fraction of his practice that he did, or that he didn't do, excuse me. In other words, let's say he was supposed to practice for an hour and he only practiced for 45 minutes. Well, the part that he didn't do is the final 15 minutes over the hour. He didn't do 20, that's 1/4. But if they wanted you to give it as a percentage, we'd need to multiply that by 100 to get 25%, right?
Yeah.
So that's why the multiplier of 100 comes in. That's merely to convert the answer to a percentage. All right, let's look at this one. So this is a problem that we can just go through and calculate a lot of stuff, right? They tell us how many juniors there are, they tell us how many seniors, and then they tell you 20% of the juniors and 40% of the seniors passed on their first try. What number is what's 20% of the juniors equal?
That's 12.
So 12 juniors, and what's 40% of the seniors?
12.
So that's 24 students passed on the first time. What percent of the campers passed on the first try? Well, how many campers are there total?
90.
So it's 24 over 90. Again,
it's 26%.
Right. Again, we have to take that fraction, which is going to be 0.26, and we have to multiply it by 100 to turn it into a percent. And that gives us 26%.
Okay.
It's funny how some of these are multiple choice, but not all of them. Ah, I've seen this before, this problem. One of my other, did you give me that? I don't think so. No? Oh, maybe. I definitely saw number 4. Tell me how to write that.
I haven't given you any of this.
Tell me how to write number 4 as an equation, and the only part you have to read up to is that comma right there.
Okay.
So how do you say 150% of J is equal to half of K? Remember, we don't want percents in equations. Percents don't, you got to convert percents to decimals when you're talking about an equation.
1.5 times J equals 1/2 K.
Exactly. And I'm going to make it 0.5K, okay? Merely because you gave me that as a decimal, I'm going to make that a decimal also.
Okay.
Now, the goal isn't to solve for J or K, which we can't do anyway. The goal is to solve for that, j over k. So
Okay.
how can we get j over k? How can we fiddle with that algebraic equation and end up with exactly j over k? What would be a good starting spot?
I have no clue.
How about if we divide by k?
Okay.
So the next line would read 1.5j divided by k equals 0.5. Notice I merely moved the k to the other side. Now we're halfway there. We got j over k, but we got a coefficient in front of it. So how do I get rid of that 1.5?
Divided by 1.5?
Divide 0.5 by 1.5. Yeah, in other words, divide both sides by 1.5. Okay? So now that's going to cancel with that, and I'm left with j over k equals that. Well, what is that answer? What's 0.5 divided by 1.5? Simplify.
1/3.
Yeah. And that's what j over k is equal to. If they would have asked for k over j, well, then I would have started by dividing both sides by j, right? In other words, if they want k over j, well, I can get that by dividing both sides by k. So my second step would be this, and I'm left with this. Now I just have to get rid of the 0.5, divide both sides by 0.5, and there's my k over j. It's equal to 3.
Okay.
So whenever they ask for things like ratios, a j over k, it usually means you can't solve for j or k on its own. You can only solve for that fraction, j over k. Because otherwise they wouldn't give you the problem like that. They would have said, what's j and what's k? All right, let's look at number 5. We got j equals 4l, and we got l equals 0.2m. Then j is what percent of m?
Can't you just use substitution for this?
It's a good starting spot. It doesn't quite get you the whole answer, but after you substitute, what do we have?
J equals 80% M.
Not percent. We're going to leave it in decimal until we're done.
Okay.
And now, what percent of j, excuse me, j is what percent of m? What do I have to do to figure that out? Don't I need j over m? If you told me what j over m was, that's saying what percent is j over m? Almost. In other words, we're going to divide both sides by m. So we get j over m equals 0.8. So what percent is j over m?
80?
Yeah, 80%. Because we know we have to multiply that by 100 whenever we convert a decimal to a percentage. But it's best to not introduce the percent sign until you're done. In other words, once you get it down to this point here, where I get j over m is equal to 0.8, now I know my answer. And I can convert it to a percentage real easily. But you don't want the percentages up in this part of the problem, because you can't solve equations with percent signs in them. They all have to be converted to decimals. All right. Number 6. Almost everybody has trouble with word problems, and it's because they never start at the right spot.
Okay.
The right spot is the very last part of the last sentence. usually. When they say what percent of the full retail price did Gia pay for the 3 tickets, that means I can write that like this. What Gia paid divided by what the retail price was. What's the retail price for all 3
$8.
That's for 1. What would the retail price for all 3? So that's how I'm going to come up with my answer. Notice that that's what we need to do. In order to figure out what percent of the full retail price Gia paid for the 3 tickets, we have to take what she paid and what the full retail price would have been. Well, we're told that $8 is the retail price. Let's figure out what Gia paid. What did she pay for her 7-year-old daughter who got a 50% discount?
$4.
And what did she pay? Hold on. So she paid $4 for her daughter. What'd she pay for her mother?
$6.
And what'd she pay for hers?
$8.
So there's our ratio. In other words, this is what she paid, and this is what she would have paid without any discounts. So that's 18 over 24. What decimal is that? And then what percent is it?
That's 3/4, and that's 75%.
Okay. So all of these problems tend to be pretty much the same. You sent me 2 documents, right?
Yeah.
Let's see if I can figure out how to get both of them up easily. Move that out of the way. Let me hit that. Oh yeah. Okay. Learning this Windows 10 gradually. Okay, so for questions 7 and 8, we have to use this table. Now, first of all, when you read these tables, notice the right-hand column is always totals, and the bottom row is always totals.
Okay.
They're giving you each category. They're telling you how many freshmen are taking college algebra, how many are taking Calc 1, how many are taking Calc 2, how many total freshmen there are. This total down here is how many people are taking college algebra. This total is how many people are taking Calc 1, so forth and so on. And there's 639 total students. Oh, I see what we did here. I skipped 7, didn't I? Well, that's all right. Let's finish 8. So,
okay.
Approximately, what percentage of sophomore and junior students are enrolled in Calc 1? Well, how many sophomore students are enrolled in Calc 1?
61.
How many juniors are enrolled in Calc 1?
32.
How many total sophomores and juniors are there?
93.
Hold on, the total juniors is 156. Total senior or total sophomores is 212. You got to add those 2 totals together.
Yeah, I did. 61 plus 32.
No, that's the numerator. But we need the total number of sophomores and juniors. All that is the total number of sophomores and juniors that are taking Calc 1.
Oh, okay.
To get their totals, we got to go over how many total juniors are there? 156. How many total sophomores are there? 212. So there's the going to be the answer. 93 over 368. What is that percentage?
Okay.
What is 93 divided by 368?
25%.
Not quite. Do it on your calculator. But it's probably...
0.252.
Okay, so it was rounded off. One reason I knew it wasn't exactly because 9 is 25% of that, but 3 is not 25% of 8. If that was a 2, it would be exactly 25. But even with it being a 3, it rounds off to 25. So we're cool. As long as we have this table here, let's look at number 9, which also refers to that table.
Okay.
And they're giving you a different period of time. This is the fall of 2014. They're telling you that in the spring of 2014, there were 752 students enrolled in mathematics. If 38% of the students were taking college algebra, how many more students took college algebra in the spring than the fall? Well, if there's 752 students and 38% of students were taking college algebra, how many students are taking college algebra?
285.76.
So how does that figure compare with the number of students taking college algebra in the fall? How many students were taking it in the fall?
Uh, 1,037.
Read it from the table. This is the number right here. You see from this table how this 256 is the total number of students taking college algebra. So
all right. Okay.
from the spring to the fall, how many do we lose?
1 second.
Well, it's approximately 30. I mean, their premise is a little shaky when they say 38% of the students were taking college algebra, because that came out to be a fraction of a student, which you cannot have. In other words, it wasn't precisely 38%. And we don't know whether it was 286 or 285. We have no way of knowing. But if I round it up, it was 286. Minus 256, 30. So 30 less students, or 30 more students, took college algebra in the spring than in the fall. Okay?
Yeah.
All right, Mark, I got to run. I will talk to you on Thursday.
All right. Thanks, David.